and Al. Then normal calories, which is like this. Okay, so you all are familiar with this, I am 100% sure, but you don't know how to convert that maybe. Okay, so in this unit, by the end of the unit, you will be able to answer so many questions which is very applicable to your real life. Let's see. So all the conversion factors are already given there. You just need to know how to convert that. That's it. Okay, so here, say for example, you are converting one food calorie, which is CAL, capital CAL, which is kilocalorie, into joules. You are using this conversion factor. Okay, so 1 kilocalorie that is CAL, which will be equal to 4,180 joules. Okay, then this kilo, you already know what's from King Henry to how to convert that. Okay, so I'll do few, like maybe 2-3 questions, and remaining you go ahead and try. So the first conversion, energy is given in joules, and you are going to convert small calories. Okay, so what we are going to do the conversion, like we need how many calories are in joules. So we are going to use this conversion. Okay, the conversion you are using in 1000 calories, there is 4180 joules. Okay, if you want to draw a T chart, you can just go quickly draw a T chart. 4180 joules, you divide with that and then multiply with the 1000. Then you will get 34.0. Since there are 3 sigfic, we will write in 3 sigfic. Okay, next one, it's given in kilojoule and you are converting into kilocalories. Okay, so we have given the conversion factor 4.18 kilojoule will be equal to 1 kilocalorie. Okay, let's go ahead and do that. So we'll write 4.18 kJ, which is kilojoule, and which is equal to 1 calories. Okay, and you will get the answer 20.7 there. Okay, next one, joule to kilocalorie. Okay, so you are picking joule value, which is this, and this to this. Okay, so we are going to convert 4180 joules will be equal to 1 kilocalorie. Okay, so you will get the answer 0.0612 kilocalorie. Okay, so now we need to do one more example maybe. Which one you want to do? Kilojoule to calories. Okay, kilojoule is what? This much. So you are going to divide 4.18 kilojoule, and calories, which is normal calorie, which is what? 1000 calories. And your answer is 4,450 calories. Okay, so those are some basic information. We will see different units going forward. Okay, now let's start the first topic, introduction to thermochemistry. Then before we start, I said there are some vocabularies we have to learn, right? Okay, the first one, here we won't say reactants, reaction, or products, or reaction proceedings, nothing like that. In thermochemistry, there are only two objects. Our universe is classified into two things. Say, for example, what you are observing, that is called a system. Say, for example, if you are conducting a reaction in a test tube with the ingredients in it, that is your system. the test tube and the ingredients in it, that is the system, and everything outside is called surroundings. Okay, so we have system and everything outside is surrounding. So our universe is actually the combination of system and surroundings. So whenever I say system, that is every reactant, including whatever whatever vessel or apparatus it is carrying that. Okay, so we are going to talk about how the energies are going inside to outside, that from system to surrounding or surrounding to system. Okay, so that's the first vocabulary you need to know, which is system. So the part of universe you are observing, okay, that is called system. And surroundings, everything other than what you observing is called surrounding. Okay, the system, there will be different type of system. We don't need that. Like in advanced chemistry, we are not much talking about it, but you need to know one is open system, the other one is closed system, and the third one is isolated system. I'll give example so that it will be easy for you to easy identify that. Okay, so example, if you have a hot cup of tea or a coffee, okay, that is an example for open system, because we know that the coffee, the some of the water molecule will evaporate and it can easily exchange energy with it. That means it will exchange both heat and energy with the surrounding. This system is open and it will exchange both heat and energy. Okay, then second example, same coffee cup. Okay, same coffee cup, but this time I've closed that with the lid, completely closed. But we know that it is a cup, so still the energy can be go outside, but no matter. So closed system can exchange only what? Only energy, no matter. That means no water molecule or no ingredients are escaping from that. Third example I'm going to say, see, I want to drink the coffee later, so I kept my coffee in a thermally insulated coffee mug. Okay, so thermoflask. Okay, I am using a thermoflask. It is completely insulated, so it cannot exchange heat for a while. I won't say for until the end of the life, right? But we know that like after 2-3 hours it won't exchange. So it cannot exchange both the heat or matter with the surroundings. So that type of systems are called isolated system. But if you are doing in your in your kitchen, or in your if you're making coffee or cooking, or if you're doing a reaction in our, we usually use most of our system in open systems, so. But when we go to physics, if you are taking physics next year, we will talk about, you will need to know different isolated system, all those things. Okay, now okay, let's go ahead and talk about heat. Okay, so until today, I know most of you are confused. What is the difference between heat and temperature? If I ask you what is heat, you will give me maybe a lot of answer that may not be correct. Okay, so heat is the transfer of energy. Okay, it is the transfer of energy. We know that if we have a hot body, heat always transfer from hot body to what? Cold body. So that transfer of heat is called energy. Okay, heat always flow from hot body to cold body. Okay, what are the different types of transfer? We can do an experiment when we do this in a class. So first one is called conduction. You all know that conduction. That means two objects are touching each other. If you are touching if you are touching a hot object with your hand, you will feel hot, right? That is called conduction because they are touching each other. Okay, then convection is a method of transferring energy through fluids. Say for example, air conditioning is a very good example. We know that, like, if our room get hot, our thermostat will realize, oh, that temperature is high, then it will transfer a message, then AC will run, and there will be cool air coming, and after few seconds your room temperature will go down to whatever temperature you set. So that type of heat transfer is called convection. Okay, and the last one, we know that we are getting energy from sun in terms of what? It's like radiation. There are so many radiations. Okay, we don't know, we can't see, like we can't feel, but we know there is that radiation. So these are the different methods of transformation. Okay, heat, we cannot measure heat, but we can do only what heat is always do. We can do calculate the energy. Okay, there is a method of calculating. We'll do that in a minute. Okay, and heat is the common unit of heat. We have seen some of the unit a little bit ago. The common unit will be what? Joules or kilojoules. Okay, now just think about this. Okay, now the next one is called temperature. Temperature, what is temperature is? Okay, we already learned in gas law, according to kinetic molecular theory, when temperature increases, what will increase? Kinetic energy. Okay, so that is a measure of average kinetic energy of particle. It is a measure of average kinetic energy of particle. Or in simple language, we can say it is a measure of what? It is a measure of hotness or coldness of an object, right? So, as you know, temperature can be measured, right? When you go to hospital, if you are sick, the first thing they will check your body temperature, right? And then there are thermometers in our room. We can check our room temperature, right? So temperature is measured. And we know that we are using Fahrenheit as a unit, but in metric system, the only two units we are using is what? One is degrees Celsius. We already learned because we learned by gas laws, right? Or Kelvin. So this will be the unit you will see also in this unit. Usually you will see more degrees Celsius. In gas law we are converting everything into Kelvin. You know the reason why we did that. Okay, so now remember the Canva code we watched, how the particles are moving when you increase the temperature. So here I have two boxes. Look at the movement of particles, and can you say which one will have higher temperature? Yes, this one it's moving like you see the tail. Okay, it is moving faster. Faster means it has higher kinetic energy. That means it has higher temperature, right? And also there is a direction is giving. We already learned that heat is always flow from hot body to cold body. So you can answer that. Okay, this box, I may name this. This is A and this is B. Okay, box B has higher temperature, right? You know, because molecules moves faster in that box, and also flow of energy direction. Okay, those two things, you saw an arrow which is going from B to A, it is showing there. That means the higher temperature to lower temperature. Okay, that is pretty much it for topic 1. Okay, now introduction to thermochemistry. Okay, okay, so let's go. Okay, definitions. Okay, we already know what is energy is. Okay, the ability to do work. Okay, or ability to generate energy or produce heat. That is called energy. Okay, so basically we are talking about the energy of a system. Okay, okay, so everything in the universe has a specific amount of energy. Say for example, if you have 1 cup of milk, okay, it has a specific amount of energy. After drinking that milk, you will get a specific amount of energy. Or if I'm burning a log of wood or a paper, okay, everything will release energy. So when combustion, we already learned that. Okay, so if we are burning something, you will get heat, and that is called combustion. Okay, so what is the source of this energy? How paper can produce energy, or how wood can produce energy, or how milk is providing us energy? That is the one we are going to look here. Okay, we'll talk about this in a minute. Okay, so basically there are 2 type of energy. You might have heard that: potential energy and kinetic energy. Okay, so kinetic energy, we already learned a little bit about of kinetic energy. It is energy which is associated with the movement. Okay, if something is moving, that is because of kinetic energy. Say for example, if you heat a gas particle, that will go very faster, right? We already know that. But if you are heating a solid, what will happen? Like uh, we know that solids are very, very, very closely packed. They cannot move, right? But I'm heating a solid. I'm providing energy, so they all will get kinetic energy. So they will do what? They will like vibrate in their positions, right? So like that, there are different types of kinetic energy, you can see, or different type of movement which is producing kinetic energy. Okay. Then next one is potential energy. Potential energy is not like energy associated with the movement. It is energy at rest, we can say, or it is a stored energy. Basically, this is one very important here. These 3 are like we need only, like in physics, I would say. In chemistry, we are focusing on chemical potential energy. Okay, the source of chemical potential energy is what? The chemical bonds. Okay, when a carbon connected to carbon, or connected to hydrogen, or connected to oxygen, or connected to another atom, or connected to chlorine, all these bonds, we know that there is one molecular. That is Coulombic force of attraction, not intermolecular. Coulombic force of attraction, right? Those forces, the attraction is carrying energy. So that is the source of all energy, which is you need to answer based on those questions. Okay, so basically we can classify into kinetic energy, but there are different type of kinetic energy. Potential energy also different type. So here in chemistry we are focusing only on thermal energy and potential energy. So this is a quick review of that. Since you are new to that, you just go see to understand what is potential and kinetic energy in general terms, not in chemical potential energy. So if an object's a roller coaster, right? When we have seen this maybe. So when you are very high up positions, and we know that when height increases, then that will have high potential energy. When it's going down, potential energy will be converted into what? Kinetical energy. So the total energy of a system, that has another name, we are going to talk about that. It is called total energy. Okay, you can just write total energy now. We will talk about internal energy in a minute. So it is the sum of potential energy and kinetic energy. Okay, already we said potential energy is a stored energy in bonds. So when a reaction happen, these bonds may be break or reform and form new bonds, so that there will be bond breaking needed energy, and bond formation releases energy, so though there will be energy change. Okay, then thermal energy. Okay, thermal energy is the form of, basically when we say heat energy, that is called thermal energy. Okay, we are going to talk about how the energy interactions are happening.